Hey guys, what's up? Me again. Back to round out your week. Today we're looking at a really cool topic called inscribed angle measures. We've already talked about what an inscribed angle is. Recall that an inscribed angle is an angle whose vertex is on the circle. Vertex on the circle. And what we're going to do is we're going to solve problems that relate to the measure of an inscribed angle to the bend of the intercepted arc. So in order to look at this, let's look at an example here. And again, the question is, how do you find the measure of an inscribed angle? So let's take a look at this picture here. I'm going to call this the center of the circle C. And here we have our inscribed angle. We know it's an inscribed angle because that vertex is right there on the circle. Okay. And that angle, angle ABD, has a relationship with arc BD. And that's what we're going to discover, or sorry, arc AD. That's what we're going to discover today. So let's say that I know this AD has a measure of 60 degrees. So, knowing that that bend is a bend of 60 degrees, that arc AD, what would be the measure of angle ABD? This is what we're trying to find down here. So it's kind of tight there. X degrees. What would that be? Well, I always tell you guys in math, when we want to learn something new, we go back to something old. Well, in yesterday or day 2 video, we talked about central angles. Well, I could connect 2 points here. I'm going to connect points C and A to make a central angle. What would the measure of that central angle be? Well, again, that's the easy one. The central angle is always equal to the bend of the arc that it intercepts. So if the bend is 60 degrees, that central angle has to be 60 degrees as well. This angle right here is 60 degrees. Okay, well, how does that help us? Well, notice how I also created a triangle. Okay, and we know a lot about triangles. A lot about triangles. Well, let's take a look at that in the triangle here. Let's take a look at angle BCA. What would this angle have to be right here? Well, what I see is these two angles are supplementary angles. So I can just do 180 minus 60 to get 120 degrees for that angle. Okay. Helpful, but it doesn't give me the one that I want. Now, here's the really cool part. You ready? Take a look at triangle ABC. What kind of triangle is it? Now, you might be saying obtuse. I agree. It's an obtuse triangle. But the more interesting thing is that this triangle is also isosceles. Why is this triangle isosceles? Well, if you notice, both segment CA and segment CB are radii. And radii in a circle always are congruent to each other, right? That's the definition of a circle, right? C is equidistant from any other point on the line. So that triangle is isosceles, which means that angle B and angle A have to be congruent. That helps us because how many degrees are left? Well, I know that angle, right? I know that these two angles have to be congruent, and I know that all three angles of a triangle add to 180. So 180 minus 120 gives me 60. So that 60 degrees splits evenly between this angle up here and this angle down here. So 60 divided by 2 gives us that x equals 30 degrees. And what I want you to do is note the relationship between the angle, the inscribed angle, and the bend of the arc. Well, you should notice that our angle is equal to half of the bend. Now, the question that I would ask is that always going to be true, or is that just happen to be true in this instance? Well, to see if this is always true, here's what I want to do. Give me one second. I want to make this just a little bit bigger. There we go. We'll look at this a little bit bigger. To figure out if it's always true, I have to use letters. So check this out. Find center C. I'm going to say that this bend is A degrees. That's a lowercase a. What I want to prove then is that this angle down here is always equal to A over 2. If I can prove that, then we know that the inscribed angle is always half of the bend of the arc that is intercepted. So we're going to prove this the same way. I know that this angle right here has to be A degrees. I know that this angle here has to be 180 minus A degrees. Because those two angles are always supplementary. So if that angle is 180 minus A, I know that these two things are congruent because they're radii again. So what I know is that my angle X has to be equal to 180 minus 180 minus A over 2. Because I know to get this, I have to do 180 minus this angle, which is already 180 minus A. And then I have to divide by 2 because it's isosceles. Okay, I'm going to give myself a little more room here. Let me just rewrite that. It's got to be 180 minus that angle of 180 minus A over 2. And when I distribute this negative, I'm going to get 180 minus 180, right? This is going to be plus A over 2. And what happens with the 180 and the minus 180? Well, they cancel each other out, and I get X equals A over 2. What this tells me then is that this angle right here, X, this angle here, always has to be half of this bend. Now you may say, hey, that only works if it goes through this. What if I had an inscribed angle that didn't have one part of it going through the center? Well, guess what? It still works. Let me just show you quickly. What if I had an inscribed angle that looks like this? Yeah. Right? What would the measure of this angle be compared to this bend up here? Well, again, I can always just go back to what I know from before. If I called this X degrees, this would have to be X over 2. If I called this Y degrees, this would have to be Y over 2. Okay? So my whole angle here is X plus Y over 2, which becomes X plus Y over 2. Okay? So this is my angle, the big angle right here. What's my arc? Well, my big arc up here is X plus Y. So I still get that relationship, right? If the bend was X plus Y, the angle would be X plus Y over 2. Okay, now the proofs might be a little weird for you, but let's get this, let's write down our rule here. One more thing for our rule. Anytime you have an inscribed angle, this is the angle, this is the bend. Don't get them mixed up. It's easy to get them mixed up. Our formula is angle equals bend over 2. Okay, and this is for inscribed angles only. Right? For central angles, angle equals bend. But for inscribed angles, angle equals bend over 2. So let's take a look at some examples. So here's what we know. We know that bend is 102 degrees. My question then is, what is the measure of angle A? Okay. I want to know what the measure of angle A is. So I'm going to put an X in for it. Okay. And I know my formula. I always want to go back to this because sometimes we're, in a sense, taking the number divided by 2. Sometimes we're going to multiply by 2. I want you to think of it as this way. Angle equals bend over 2. So what's my angle? Well, my angle here is X. That has to equal the bend. What's my bend? It's 102 divided by 2. So that angle X equals 51. So the measure of angle A is 51 degrees. Let's try another example. Here's what I know. The angle is 26 degrees. My question is, what is the measure of arc BC? Okay. How is this problem different than the one I gave before? Well, before I gave you the bend and asked you to find the angle. Now I'm giving you the angle and asking you to find the bend. So I'm trying to figure out this bend, so I'm going to put an X here. But again, I'm going back to angle equals bend over 2. So my question, what is the angle? Well, in this case, I know the angle is 26. That has to equal the bend. What's the bend? That's X divided by 2. How would I solve that equation for X? Well, quite simply, I just multiply 2 on both sides, and I get 52 equals X. So I know arc BC is 52 degrees. Okay. Take a look at a couple more ones, though. Ready? Because these can get a little bit harder. C is the center. Okay. Here's what I'm going to give you. I'm going to give you that this is 140 degrees. I'm giving you a bend. And I want you to find the measure of angle dab. Oh, I wish you could see me because I just did a pretty sweet dab, even though that's not cool anymore. Okay, so I want to find the measure of angle DAB. So I want to find this. Now you got to be careful here. Some people might just say, oh, I'll do 140 divided by 2 is 70. We can't do that. Okay, we can't do that because this bend here is not intercepted by this inscribed angle. This inscribed angle intercepts this bend over here. Now, if I knew this one, I could divide by 2 to get x. But I don't know that one. But here's the thing, I can find it. Once again, pay attention to diameters. Excuse me, segment AB here is a diameter, which means this arc from A all the way to B has to be a measure of how many degrees? That's right, 180. Which means how much is left for little arc DB? Well, little arc DB must be 40 degrees. Now I have the inscribed angle, and I know the bend of the arc that is intercepted by that inscribed angle. So again, I'm going to do angle equals bend over 2. 40 divided by 2 is 20. So I get x equals 20, and DAB is 20 degrees. Okay. Let me show you one more. And we'll be done. Oops. Here we have an inscribed triangle that has 3 inscribed angles. So here's what I'm going to tell you. This angle right here is 80 degrees. And I'm going to tell you that this angle right here is, let's say 70 degrees. My question then is, find the measure of minor arc, right? The bend of minor arc AB. Okay, now how are we going to do this? Well, I like to put an X for what I'm looking for. I'm trying to find that bend, X degrees. Now, I can't do 80 times 2. I can't do 70 times 2, because those are not inscribed angles that intercept arc AB. This arc AB right here is intercepted by this inscribed angle. Okay? That's the angle I need to find. Okay, so there's a couple of ways you can solve this problem. The way that was natural to me was I said, okay, hold on here. This is a triangle. This is a triangle. These 3 angles have to add to 180. 70 plus 80 is 150. That means this angle right here is 30 degrees. Now I have the angle I care about to find this arc that I want. So I'm going to say angle equals bend over 2. Multiply the 2 over, and I get x equals 60. And I find the measure of arc AB to be, the bend of arc AB to be 60 degrees. Let me show you another way students might solve that. Okay. Somebody might say, okay, if this inscribed angle is 70, the angle equals bend over 2. And I'm going to find this bend. Here, let me change that to an x2. Right? This bend then would have to be, when you multiply the 2 over, this one would have to be 140. And then let's find this bend over here, since this is 80, right? 80 must equal y over 2. So this bend must be 160. Well, I know the total bend of a circle has to be 360 degrees. So 140 plus 160 is 300. The total bend is 360. 360 minus 300 would make this x equals 60. And I could get it that way. Okay, so more than one way to solve that. Both are kind of interesting ways to look at it. That's it for today. Have a great weekend. Stay safe out there. Wash your hands. Don't forget to like, comment, subscribe. And I will talk to you guys later. Bye.